In this video, we'll look at graphing linear equations using the slope of a line. First, we'll talk about what the slope represents, then we'll talk about how to calculate the slope, and then we'll look at graphing using the slope and the y-intercept. The slope measures the steepness of a line. We write that by writing the ratio of the vertical change, the difference in the y's, to the difference in the x's, the horizontal change. We can use any 2 points on the line to calculate the slope. If you use 2 points and I use 2 different points, we'll still get the same slope. The slope is consistent throughout the line. If we have a line with a positive slope, that means the line is rising from left to right. If we have a line with a negative slope, the line is falling from left to right. A vertical line has an undefined slope. If I tried to plug the coordinates of these 2 points into the slope formula, my denominator would be 0 because there is no run, there is no horizontal change. And I know that if I try to divide by 0, I get an undefined result, so I would have an undefined slope. A horizontal line, the 0 would result on top in the numerator, so that's just a slope of 0. Okay, let's take a look at a graph that we have a line graphed on, and we can see 2 points on the graph. We actually have a third down here, but the 2 we're going to use. This point on the y-axis, and the second point has an x-coordinate of 2, a y-coordinate of 5. To figure out the slope from the graph, we can do that without using the slope formula. We just think about how do we go from the first point to the second. The slope is like a road map. So to get from the first point to the second point, I must go up 1, 2, 3, 4 units. So my rise is 4. From there, to get to the second point, I still have to go over 1, 2 units. And that was 2 units in a positive direction, so that's positive 2. Remember, it's always rise over run. So in this case, it is 4 over 2. So we write our slope as rise over run. 4 over 2 gives me a slope of 2. And m represents slope, so I can write it as m equals 2. Alright, if we chose this third point and we tried to go from the lowest point to the highest point, would we get the same slope? Well, we would get a different rise and run, but we should get the same slope. To go from this lowest point, we would have to go over 1, 2, 3, 4 units. So our run, in this case, is 4. From there, we would have to go up 1, 2, 3, 4, 5, 6, 7, 8. So my rise would be 8. We would still write it as rise over run. In this case, that would be 8 over 4. Which still gives me a slope of positive 2. So if I write the slope as rise over run, I may have different values for the vertical change and the horizontal change depending on the points I pick, but the resulting slope will be the same. We do want to reduce it. If we can divide and get an integer, then we want to do that. If we can reduce it to a fraction that's simpler in form, we want to do that. We do not want to write the slope as a mixed number. So if you have something like 7 over 2, leave that as 7 over 2. Okay, now let's take a look at using the slope formula. If we know 2 points on the line, we don't have to be able to see the graph. We can use the slope formula. Label one of the points, point 1, so x1, y1. Label the other point, point 2, x2, y2. Then plug in those coordinates into the slope formula to calculate the slope. So y2 is first, minus y1. Our y2 is negative 4, minus y1 is positive 6, over x2 is negative 2, minus x1, which is positive 3. It's always subtraction in the formula. If you're subtracting a negative, then you're going to have to be careful with your signs. In this case, we weren't. We had 2 positive coordinates for point 1. Now we simplify. Negative 4 minus 6 gives me negative 10. Over negative 2 minus 3 gives me negative 5. I divide. A negative divided by a negative is a positive. 10 divided by 5 is 2, so my slope is positive 2. The next thing we'll look at is the slope-intercept form of an equation. If we solve for y in an equation and we put it in the form y equals mx plus b, where m and b are numbers, like y equals 3x plus 2. M, the coefficient of the x, represents the slope, and b is the y-intercept. So when an equation is written in slope-intercept form, and that's a very important part, I can't look at this equation in any other form and make this assumption. I have to say, when an equation is written in slope-intercept form, the slope will always be the coefficient of the x variable. The y-intercept will be the constant term b. Okay, let's take a look at an equation in slope-intercept form. We have the y by itself. It has a coefficient of 1. We have mx plus b. So if we think about y equals mx plus b, we know that m has a value of 1/4, so our slope is 1/4. Remember, m always represents the slope. B is the y-intercept. The y-intercept is actually a point, so I need to write an ordered pair. The x-coordinate is 0. The y-coordinate is this constant b, and that's positive 3. So those are my two key points. If I wanted to graph this line, now I could plot the y-intercept and use the slope to get another point on the line to draw the graph. In this equation, again, we're identifying the slope and the y-intercept, but now we do have to do something to get this equation in y equals mx plus b form. We have to divide by the coefficient of this y. So we're going to divide all terms by negative 2. We're going to get positive 1y equals negative 3x minus 8, because a positive divided by a negative is a negative. So my slope is m, the coefficient of the x. My slope is negative 3. My y-intercept is negative 8. I write that as an ordered pair, the x-coordinate of 0, a y-coordinate of negative 8. Okay, in this case, we're going to graph a line that's in slope-intercept form. We've learned about the form. We know it's y equals mx plus b, where m is the slope, b is the y-intercept. So the slope of this line is 1/4. That's rise over run. My y-intercept is positive 3. I know that because it's the constant. I have an x-coordinate of 0, a y-coordinate of positive 3. When we graph, we have to start with the y-intercept because that's a point on the line. So we always start with that. The slope then tells us how to get from that point to another one, but we have to start with the y-intercept because that's a point on the line. So we put a point on 3 on the y-axis. From there we rise 1, run 4, and put another point. If we wanted to get a third point, we could. We could just rise 1, run 4 again. Sometimes that helps you draw a more accurate line. And drawing lines for me on this thing is kind of tough, but hopefully you'll do fine on your paper. You see what I mean? There we go. That's pretty good. I extend it a little bit and put an arrow to show it continues in both directions. Our next equation is in standard form. ax plus by equals c. So before we can graph it using the slope and the intercept, we have to solve for y. We could graph it using the x and y intercepts like we did in a previous video, but in this case we're going to solve for y by subtracting 3x, from both sides. The x terms cancel out and leave me 4y equals negative 3x plus 16. I want to divide everything by 4. So I get y is equal to negative 3/4 x plus 4, because 16 divided by 4 is 4. So my slope is the coefficient of the x, that's negative 3/4. My y-intercept has an x-coordinate of 0, a y-coordinate of positive 4. I always start with the y-intercept, so I go up to 4 on the y-axis, and I put a point. From there, I use my slope of negative 3/4, which tells me the rise is negative 3, so I'm going down 1, 2, 3. I run positive 4, 1, 2, 3, 4, and I put a point. If I wanted to get a point in the opposite direction, think about another way I could write a negative 3/4. We know that negative 3/4 can be written as negative 3 over positive 4, or positive 3 over negative 4. I can't put a negative on both because then I've turned it into a positive slope, but I could write it as positive 3 over negative 4. If I did that and I started from my same y-intercept, my rise would be positive 3, so I would go up 1, 2, 3. My run would now be negative 4, so I would go back 1, 2, 3, 4 to the left. So I would have points that lie on the same line. They would just be going in opposite directions. Sometimes you need to do that because your first point is somewhere on the graph paper that you can't move in one direction. So, and I don't know why I keep messing that up on the end, but it should just extend out and have an arrow to show that it continues infinitely in both directions. It shouldn't curve like that. It should just be a straight line. Alright, when you complete this lesson, when you finish the homework, you'll be able to write an equation in slope-intercept form and determine the slope and the y-intercept from that equation. You'll be able to graph a linear equation using the slope and the y-intercept.